welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with our guest, Vanishree, co-founder and CEO of Fermah. So thank you so much, Vanishree. We're very, very excited to have you here today for this episode.
Thank you so much. It's great to be here.
Yeah, thank you, Vanishree. I'm wondering if you could first introduce yourself, start off with maybe your story on how you got into first cryptography and then the Web3 space, and now focusing on ZK.
Yeah, sure. So now I'm like you said, I'm the founder and CEO of Fermah. Let me tell you a little bit about Fermah, and then tell you how my journey led to this point. Fermah is a universal proof generation layer. It can generate proofs for any proof system in a cheap, performant, and reliable manner, and it functions as a marketplace where the supply side consists of machines like FPGAs and TPUs, and for the demand side, Fermah can generate proofs for any instance in which ZK is used. So this is what we are building right now. We are actually right now on DevNet, permission DevNet. And my journey towards this, so this company is only about a year old. Founded this company late last year, but my journey towards this started about 20 years ago. And I came across zero-knowledge proofs. My professor at the time told me about zero-knowledge proofs 20 years ago when I was doing my undergrad in India. And the first time I heard about zero-knowledge proofs, just like anybody would react, right? How is this even possible? Where you can convince somebody of the verity of a statement without even telling them any details about why that statement is true. How is it even possible? And the impossibility at the face value nature of this just got me very interested in this topic. And in the following months, my professor again gifted me this book by Neil Koblitz, who is a famous mathematician and who wrote this book on, I think it's called A Course in Number Theory and Cryptography. Number theory, which is the underpinning technology of cryptography, was very well explained in that book. It almost reads like a novel. You know, he manages to explain only the things that are required to go further, but not so much that you're completely spoon-fed and your mind stops thinking. You start wondering about things as you go further. I would highly recommend any of your viewers. It's a beautiful book. So I spent months just pouring through the pages, an entire summer, pouring through the pages, staring at the ceiling, thinking about how these theorems could be solved, and then I'm from a remote town in India, and I wanted to study more of this. So I came to the U.S., did my PhD at UCLA in cryptography. My advisor's name is Amit Sahai. He has done some foundational work in zero-knowledge proofs. I had a chance to work with him in building some zero-knowledge proof protocols, MPC protocols, etc. And then later I worked at a few projects in Web 2, and I had this dream of sorts to somehow finally apply things that you could study in cryptography, right? And I came across Meena pretty much at the very beginning. I think I was one of the first few employees, and I worked on Meena for about 4 years. Had an amazing time. Worked on the consensus protocol, the ZK snark that's in Meena, and I also worked on another project called Midnight after that, and so all along I've I've longed for wanting to work on ZK and apply ZK in the real world. And throughout this process, I realized that there is one gap. And that gap is not having scalable infrastructure to generate zero-knowledge proofs that is accessible in an easy way. And when I realized that, I made sure that this is a prevalent and deeply felt problem that is good enough to put many years of my life behind, and started this company late last year. This is a little bit about my background.
Yeah, thank you so much, Vanishree, and it's very amazing to see how far you've come from first discovering cryptography and ZK in your undergrad years to working on these projects, and then finally starting Fermah. So I think that's a very, very inspiring journey. I'm wondering, like, based on that, I'm wondering about your thoughts on the evolution of the ZK space. How have you seen the space evolve over the years, and how would you compare the space when you first started to now in terms of the current challenges being addressed, if we have different priorities now compared to in the past? Are there any aspects that you foresee becoming challenges in the future as we are working on, as you said, applying ZK in the real world, as we're working on greater adoption?
That's a great question. I think I'll split my answers into three parts: what has happened until recently, what is happening now, and what is likely to happen in the future, in my view. What has happened so far is that there has been a few switches in the focus in ZK. So it started many decades ago. ZK was invented many decades ago, right? It evolved within the bounds of, mostly within the bounds of research until recently, until crypto took it up and made it more feasible. But until then, it was mostly in the research area, and even within the research area, there were shifts. There were initial focus on building specific protocols for specific use cases. For example, let's say you have a secret, and you know in HTTPS there is G to the power of a secret, right? You know that, and let's say you want to prove that, and that proof is very, very simple. You can create this very simple proof called a sigma protocol to prove your knowledge of an exponent, and there were this category of there was this line of research that catered to this kind of problems where you're actually proving a specific computation. And then there were these generic protocols that catered to these generic computation. In any computation, you can use these protocols to prove. And there were the directions in which the evolution happened in research was mostly in reducing the number of interactions. So at that time, they were mostly built in an interactive manner. These proof systems were built in an interactive manner. And SNARKs, or even before that, the so-called NISX, non-interactive zero-knowledge proof protocols, came a little bit later. And until then, most discussions were happening in an interactive setting. And in that setting, all the dimensions and the directions in which the evolution happened were reducing the number of rounds, the security assumptions you can make, the computational hardness assumptions you can make based on which you can rely your proven security, and the other things were the security model in which you would prove your protocol secure, right? Do you prove them to be secure against a party that is lightly resourced, generally resourced, or somebody who has a supercomputer, right? What level of security can you prove your protocol secure? What is the model in which you can prove your protocol secure. So these were the variants that happened. These were the kind of things that were happening in the research industry, right? And then we started off in our industry with specific proofs, such as in Zcash, right? There you had to prove a specific statement where you are not double spending, basically, right? The proof just made sure that you are not double spending, and you're the right person to spend these things like that. It was a specific function, and as ZK got picked up so widely, people started building those specific ZK protocols, and tools came around which helped us build specific ZK circuits, the custom ZK circuits, right? Zircom, Noir, etc. And people felt the need to have something even easier to adopt ZK. And that's when ZK VMs came to, which significantly reduced barrier to entry and engineering costs and time to market. And so that is the evolution so far. And what could happen going forward is in a few directions, right? One is a discussion that recently happened on Twitter, where I put forth my thesis that for a project that scales to an extent, to a mature extent, that these bootstrap constraints are no more constraints, the time to market and engineering costs are no more constraints for those projects. Does it make sense to switch from ZK VMs to circuits? And if that becomes a demand, will there be a rekindled focus on improving these tooling to do custom circuits well? That is one direction. There are many other interesting directions, right, that we probably should be thinking about, and they are: can we have this trusted setup done in a way that multiple projects can use? Right now, of course, multiple projects can use. How can we increase the generality of it, right? One, of course, is by increasing the size of the setup. There are a few other ways one could think about, and I think a focused research on this can take us a little further to help the industry. There are other areas such as upgradability, ZK upgradability, right? Think of Zcash. Zcash had a different proof system, and then it switched its proof system, right? And what happens to shielded transactions what happens to shielded transactions that happened when proof system 1 was used is that when you're trying to use the money that you received in that phase, the previous phase, you as far as I understood, I don't know the current situation, but at least when I researched a while ago, what had to be done was you had to unshield and then come to this world. There was no direct way to go from shielded to shielded. You had to unshield and go to the shielded version, and it's a natural direction because otherwise because here you have a proof system. You're speaking the new proof systems language, right? If you're continuing to speak the old proof system language, then this proof system needs to understand this old proof systems language, and the translation is really cumbersome, which involves these heavy non-native field arithmetic. It's a huge lift, right? So upgradability of proof systems. In how can you architect solutions in a way that you can upgrade proof systems easily? These are questions. These are a couple of questions. I think there are a few other questions, but I think the high level flavor of these questions is that it's not about building one proof system in a really good manner. It's about thinking from the industry's perspective, right? What for a, for for the entire industry to be able to use trusted setups, for applications to be built here, what do they need? What else do they need as they move forward, right? Yeah, those are some of my thoughts.
Thank you, Vanishree, and I do appreciate you mentioning that dynamic between generalizability and specialization from in the beginning, protocols focusing first on like general computation and then more specific computation, and then we can even see that today, as you mentioned, with the debate on building custom circuits versus ZK VMs for more generalized computation. And I also do appreciate you mentioning about not just building like a perfect proof system, but seeing it more from a wider macro lens, from what like the industry needs in general. And I'm wondering if you could go more into the most pressing challenges and problems that you see in the space right now. So you mentioned a little bit about the question of improving upgradability, but I'm wondering, in your view, what do you see as most significant problems that many players and even yourself are focused on solving, and what Fermah also is focused on solving as well?
Right. I think we have come a long way. Right there, it's become so much easier to adopt ZK thanks to the ZK VM projects. Like you're building a ZK VM. There are so many other projects building ZK VMs, and you're all you all have contributed significantly towards adoption of ZK, and so if we are to take stock of where we are and look at where we want to go is we want to abstract out the entire complexity, all the layers of complexity of adopting ZK, and let's look at all the layers through the lens of the ZK supply chain, proof supply chain, right? You start, so let's say you're a project, you want to embrace ZK. What are the things that you need to do? You first identify the logic, the business logic that needs to be proven in your application. What do you need to create proofs of? You identify that. That's step one. Step two is you need to identify the proof system, right? You need to identify the proof system, and together with that, you identify the right hardware configuration used for proving, or a set of hardware configurations used for proving. So you choose that as a pair. For some proof systems, maybe it's better to use, let's say, RTX 4090s, and for the other proof systems, it might be better to use a bunch of RTX 3090s, something like that, right? So you choose a pair, and the way you choose this pair is driven by your business decision, by your business constraints, right? What are your business constraints? The proving time and proving cost. You come with these constraints, and then you choose this pair. And once you choose this pair, the proof system and the hardware configuration of the prover, then you see who will generate these proofs. What is the infrastructure? How do we set up this infrastructure? And then you decide where you're going to proofs are generated, where you're going to settle these proofs, on Ethereum or on ZK verification layers that some projects are working on. So this is the entire life cycle, right? Along the way, there can also be aggregations of proofs, but I'm putting that under the umbrella of proving infrastructure. There also proving is happening. When you're aggregating proofs, you're actually creating a proof of correctness of a bunch of proofs anyway. So this is the high level landscape, and I believe that there is a good deal of progress in all the layers except the proving infrastructure layer, and this is a realization that I had last year, and which is why I went after this layer, and that's the layer we are building, the proof generation layer Fermah is a universal proof generation layer where the specific headache that we're trying to take away from developers by building this is the headache of having to figure out who those provers are, how many provers do you need, what are the right incentive mechanisms for these provers, how do you maintain the optimal incentive mechanisms for these provers so that you are not under incentivizing them, thereby risking liveness, or over incentivizing them, thereby making it uneconomical for your end users, right? These are the headaches, and actually one of the reasons why projects who are so advanced are not thinking about are not, they don't have a very good local prover network is because of two reasons. One, it's very hard to do. It's a project in itself. It's a resource taken away from the other business core business focus of these projects. That is why they are not doing it, and there are band-aid solutions right now for these projects because they're focused elsewhere, and rightly so. If only there existed something that is a universal proof generation layer. And the second reason why it is hard to do, it's a hard problem, is that if you're a local project, if you're a project, right? If you're an application, you go through the life cycle of a project that any project goes through. You start by bootstrapping. You start by trying to find product market fit. These are all the phases you have to go through. And when you're going through this, it is hard to think about the amount of hardware you need to set aside for this, because you don't even know the volume of transactions. It's very hard to tell, and also you're bootstrapping. You don't have that much capital to set aside heavy provers to do this, and doing it on the cloud is it's not a good solution because it can take time to generate proofs because you have to create an instance and then cut down the instance. You have to upload your setup parameters that are really huge. So all in all, the summary of my point is that it is a hard thing to do for a project to have proving infrastructure that is locally done, and when contrast that with having having a universal proof generation layer that has diverse requirements. So Fermah does not take sides, right? In terms of proof systems, we are credibly neutral. We want to get demand from any kind of application that is using zero-knowledge proofs and any proof system, right? By doing that, when you look from the supply side, you're in a position to have good utilization rates for these machines because demand is not from one project and not betting on one or a couple of projects. You are actually betting on the industry, and when you have those good utilization rates, it becomes cheaper to generate proofs because you don't have to over incentivize these underutilized machines. You can incentivize them already by giving the work and the proof generation fees. So all in all, it's a big win. Headache taken away, economical solution, right? Economical solution.
Yeah, thank you, Vanishree, and also thank you for also abstracting and mentioning the supply chain that's involved in it. It's really great to see that there are a lot of projects now who are targeting specific steps in the supply chain to make it more usable for developers, and it's great to see that Fermah is specifically addressing that proof generation layer side. So that I think that's very exciting, and very much looking forward to see how Fermah comes about. And I'm wondering on that side, if you could talk a little bit about the specific use cases for ZK in general that you're most excited about, and specifically those that may come into adoption as we are making the process within each step of the supply chain easier for developers and users?
I think there are so many amazing applications, very interesting applications, and I think within our crypto space, of course, there are plenty where you are the most important application ZK has been used for is to make execution of blockchain scalable, but through the use of ZK rollups. So that has given the important light that has brought so much attention to ZK. That is the core application that has brought so much attention to ZK. And there are other applications that are interesting too, which are currently outside of Web3, and they are criminal journalism. When you're doing criminal journalism, you can create proof of provenance of pictures you take at crime scenes through and it can be used in the court of law, especially especially in this age where it is so easy to modify your pictures. It is so easy to modify videos. For it to stand as a valid evidence in the court of law, zero knowledge proofs can be useful, where it can give you the integrity of any transformation that has happened from clicking that photo to any post-processing that had to be done. There are other interesting applications such as think of a big Fortune 100 company. They spend millions, tens of millions of dollars every year on audits. Especially the publicly traded companies, they do need to do that, and other companies also tend to do that. And these audits take millions of dollars, and these audits are manually done and error prone. What ZK can do to this industry is it can make it extremely efficient and extremely time efficient, cost efficient, and not prone to errors. And you can do that by you have the code, you have the input, which is all the transactions, and you put that in. You create statements and you generate proofs, and there is the initial setup that needs to be done. Of course, that is time consuming. Of course, there. You can even imagine projects getting built that can offer this as a value to customers like those, and they could use ZK. There is no component of blockchain here, right? There is no component whatsoever of blockchain, but ZK is a component, and this is an example to explain also my thesis that I think ZK will become bigger than blockchain. ZK will become more widely accepted than blockchain. There are parts of our world that are centralized, and I think centralization by itself is not bad. You need ability to convey integrity, and ZK is your ability to convey integrity. Another nice example is proof of solvency. Banks can prove their solvency through the use of ZK. They don't have to embrace blockchain to do this, but they can. Centralization doesn't mean that centralization and keeping all the transaction data to themselves doesn't mean that they cannot share important inferences from that data. An important inference from the data they need to share with their customers is their solvency, and ZK can help them do that, and they can still stay centralized and still cater to the part of the world, still cater to the needs of the world that they can continue that they can cater, right? And blockchain will continue to cater to the needs of the world where decentralization is important, etc. But ZK can help both.
Thank you, Vanishree. And yeah, it sounds very amazing of all of those future applications that we can see, even off-chain, even Web3 applications, like what you mentioned with criminal journalism, for example, and then even with the proof of solvency. And I find it very exciting that of the idea that ZK will one day become even more widely accessible than blockchain. As we see, blockchain has a lot of barriers to adoption, and well, ZK does as well, but there's so many projects like what we're doing and what Fermah is doing that's helping to make that ease of adoption as simple as possible. So very exciting to see where the space is going. Yeah, I'm wondering, Vanishree, if we could scope out a little bit from the ZK to just looking at cryptography as a whole in general, because I know that you had quite some extensive experience in both ZK and cryptography. I'm wondering about your thoughts on a lot of projects saying that ZK is the end game, like the end-all be-all solution. How do you compare ZK to the other, hot topic cryptographic primitives that we see, like multi-party computation, fully homomorphic encryption? Do you think we'll see a dominant approach in the future, perhaps a combination of a few? Also following up on that, I wanted to ask you if there's any other cryptographic primitives that you're personally very excited about beyond ZK.
Oh, great question. Another great question, Alice. Thank you. So I think, let me give you an analogy, a similarity, a similar situation, and that is a knife better than a blender, right? No. Or is a blender superior to a knife? No. A knife is used to cut vegetables, and a blender is useful when you want to puree your soups. And no one so when I say this, the three tools, cryptographic tools that I have in my mind are ZK, MPC, and TE. FHE is another beast, so let's keep it aside for now and address it in just a second. It's a beast, pun intended. And I think I think among these three, right? It's not true that one is superior to other at all. ZK, zero knowledge proofs, multi-party computation protocols, or trusted execution environment machines. And the reason is that they all bring to the table something in a situation where that thing is necessary. It really depends on the application. And I'll give you an example of a situation where they can come together in a way where they are solving a problem that no subset of that could have solved. They had to come together to solve something. And here is that. I'll explain it at an intuitive level. I'll leave out some technical details, but here is the core idea, right? Imagine you are generating proofs. Imagine you are generating proofs on your old Nokia phone, right? In some part of the world, old Nokia phone. You either are not able to complete the proof, or your battery dies out, or the time to generate the proof is so long that it is just unreasonable to have that phone generate the proof. So all in all, it's very hard to generate proofs on likely resource devices. What is the solution at that time? Any solution that involves, no matter which proof system you use, it does not, inside these clients, it's not going to scale with the increase in the size of the computation or decrease in the capacity of the device. And what is the solution? you can delegate proving. That's what we are doing. We are having proof generation delegated to us at Fermah. But this delegation is not straightforward in situations where the computation involves sensitive data, let's say your identity information, etc. That has to stay with the client. Now, how do you so you cannot generate proofs, you cannot delegate the information. You are in a fix. The solution to that is what we call data protected proving delegation, DPPD, data protected proving delegation, and we are actually building that. And there, all these three primitives are coming together. Here is the way they're coming together. There is ZK, of course. You need to prove. So there is ZK. Now you cannot give it to one single party because it has sensitive information. How can you split this information with not just one party but multiple parties, so that no single party knows any information, but if they come together, they can recover the information, or they can interact with each other to do some computation on the shared secret values, right? That's MPC. When secrets are shared, you perform a computation, and here the specific computation you're performing is generating the proof. So the witness data is secret shared across these multiple devices, and you do an MPC protocol to generate the proof. And TEEs come into place by for the following reason. MPC typically has overhead, right? And it typically has some computation overhead, but a lot of communication overhead. And how can you reduce that? You can reduce that by the use of TEEs. I think more details about exactly how we do it we will write about it, and we will talk about it in the near future. But for the topic here, for the question of is it true that one is superior than another? Here is an example where they all come together to achieve something that no subset of them could have achieved. So no one thing is superior than another. They all bring something to the table. And to complete my answer, I told you about MPC, ZK, and TEE, but about FHE, which is another area that is talked about. I think it's in its initial phases. It's in its initial phases of development that ZK was in a few years ago. And the good thing about our industry is that we do that. We adopt a technology that is hard but is really effective. If it becomes efficient, it can be very powerful, but it is very hard to do now. We take those things and try to do something with that. We have had success with ZK. What will happen with FHE needs to be seen. And the only thing that I would say regarding FHE is that I'm glad we are doing that with FHE. We'll see what will happen.
Yeah, very exciting, and I do really also appreciate you also giving that analogy of it's like blender versus blade. It's not just one replacing the other. Instead, each one has its own use and its own place in the industry. And I feel like even within our own industry, we have many other examples where it's not just one replacing the other, one competing against one another. I remember when like the optimistic versus ZK roll-up debate was really hot, and a lot of people were saying, well, optimistic, they have long withdrawal times, but easier implementation. ZK has their own advantages and drawbacks, but now a lot of projects are looking to combine the both, just like how with the data predictive proving delegation, as you mentioned, all of the three primitives are coming together. So now projects are thinking of combining both, like optimistic and ZK, like what ZKM is doing. So very, very interesting to see that we can see almost a collaboration emerging of these primitives, of these topics, and not just like competing against one another. So really, really great to see that. Another topic on top of that, Vanishree, now going scope, or right before we scoped out into looking into general cryptography space, Right now, I want to dive a bit deeper into the debate that you sparked on Twitter on ZKVMs versus custom circuits. And this is what you mentioned a bit earlier on in our episode. So we saw from the debate that there's benefits and drawbacks for both. And you personally in the future believe that custom circuits will overtake like general computation ZKVMs. I'm wondering if you could, from this debate and from the outcomes, if you can speak a little bit about any conclusions that you draw from the debate. So are there any new possibilities sparked from the discussion that maybe all of us haven't previously considered and you're now seeing?
Yeah, I think it is important to acknowledge the amount of impact ZKVMs have had on our space, and I also want to clarify the bounds of my argument, right? So first to acknowledge the amount of impact. They have reduced the barrier to entry. It is so much easy for a project to choose a proof system without having to spend so many months to years on rigging custom ZK circuits and spending so much money in engineering aspect of that lift. ZKVMs, I think, are here forever to stay. I don't think custom circuits will altogether replace ZKVMs. And the bounds of my argument only apply to projects that have reached that level of maturity where the bootstrap constraints go away. The bootstrap constraints of engineering costs and time to market. They have already chosen the proof system. They have a product now. What becomes important at that level of maturity is performance, because performance can take a center stage when projects compete. A good example that an example that I like to give is of Uber. Uber started off just going to market and finding a product market fit. At that time, they of course didn't spend building their own maps. They used Google Maps with whatever API that was thrown at them. They used Google Maps. It got them somewhere. And now they have their own maps, because that maps will give them the information they need to get for Uber application. They have built it. Why they have built it? Because now they are so big. They are impacting such a huge part of the population. And any improvement that they make in user experience impacts not a small set of people. It impacts that large amount of people. It makes sense now for them to put together a team that can build Google Maps, their own version of Google Maps, and a similar argument holds for projects, for applications that become so mature. Right, we're in the very initial phases of ZK evolution. Right, imagine projects becoming so widely adopted that it touches everybody's daily lives. At that time, it's easy to conceive that they would care about performance. It is not a problem for projects like those to put together a cryptography team that can improve the performance of proving done. And ZKVMs are generic. They solve certain problems, but something that is generic comes with the overhead of generality. Something that is custom can remove that overhead and squeeze out any level of performance possible by doing just the work required. So that was my main point there, while trying to think about what is likely to happen in the future as ZK evolves, as projects evolve.
Yeah, definitely. And I also agree that does depend largely on the maturity of the project. And we can see like both a combination of custom circuits being used and ZKVMs depending on the project's needs. And I do like how it's a matter of like choice. We're not really going to, well, right now we see both of them competing, but in the future, hopefully we'll see projects having the ability to choose like different design considerations based on their needs. And I feel like this topic can also, like the generalized versus specialized topic, can also be drawn to some of the other industries that we see. Like you, for example, mentioned that, well, first Uber used the Google Maps API, but then they're now using their own maps. And even for some other industries, like the evolution of like mainstream cloud infrastructure versus using it on site, using your own servers, different companies have their own preferences, and some may want to use the cloud infrastructure, which we can compare to, like, for example, using ZKVMs, and then some may want to have their own hosted servers, such as building your own custom circuits. So really depends on what the project is looking for, their needs and their wants. So yeah, thank you very much for speaking about like your conclusions of the debate and seeing how we can apply this to the grand scheme of things. I'm also wondering, going more into the Fermah side and a bit on the topic of design considerations. So what kinds of design considerations are you prioritizing for Fermah specifically? A lot of proving networks out there, they look at cost, they look at workload distribution, they look at censorship resistance. Specifically, what kinds of areas do you see as important, and what you're really trying to prioritize for Fermah?
I think we are trying to prioritize two things. One is getting the mechanism designed right. I think that is so important because proving time and proving cost will be important, and we need to squeeze out as much as possible in these two respects. Like you said, some projects, some applications care about cost, some applications care about speed, and the way we build mechanism design to ensure that our orchestration is not adding to it. Our orchestration shouldn't be adding to the proof generation time. Our orchestration shouldn't be bulky that it needs to be compensated so much that it affects proving cost. This is one of the main constraints we are working with as we are architecting our solution. And the other one is DPPD, data protected proving delegation. It is the way we are thinking about the world is not to leave out. So this not to. I think it is very easy to focus on the part where privacy is not a concern, but I think there are booming projects that where they are generating proofs on computation where privacy is involved, where the data on which they're proving has some sensitive information. So our approach is to build something both when privacy is not a concern, like ZK rollups, ZK bridges, ZK co-processors, but also projects like projects where proving involves sensitive data, and that is why you need data protected proving delegation. These are our approaches for what we are building.
Yeah, thank you, Vanishree. And also, just as a follow-up for that, how do you see the space in general transforming when Fermah comes to market, and when you guys achieve more success, how do you see the space evolving from there?
I think the goal for us is a click of a button kind of ZK adoption, where there is a very nice user interface where you choose, okay, these are the proof systems, this is the hardware configuration, or even better, you specify your constraints and your options are spit out, right? And then you choose your options. This is the kind of interface, and every time some proof generation needs to happen, it'll happen in the background. All the complexity of proof generation abstracted out. that's our goal. And the way what we are building is going to help make that happen, or help us get as close to that as possible from our side, is by saying that you don't have to worry about proof generation. You don't have to worry about incentives. Instead, what you see, the API between us and the companies are very clean in with respect to proof generation time and proof generation cost. And those are some transparent numbers that they see, while not having to worry about the complexity behind, and that complexity is taken away from them. Now ZKVMs are here. It really makes adoption of ZK very easily. So with the help of ZKVMs, with the help of universal proof generation layer like ours, and with the choice of good verification layers, be it Ethereum directly or other verification layers, it seems like an entire package for projects to embrace ZK. I think this really, I do genuinely think that this is, especially given that ZKVMs are in place, I genuinely believe that making infrastructure easy is a missing piece. And I think that'll change when Fermah becomes successful, begins successful.
Yeah, thank you. And I do also really like how you mentioned that you see all of this coming as a whole package, from ZKVMs, which address more on the general computation side, to what Fermah's building with the universal proof generation layer, and then also adding another big barrier for a lot of projects, which comes with the verification. If we're able to all work together and marry those concepts together, marry those stages of the life cycle together, then we'll see, I believe, a lot of mainstream adoption in the future. So very exciting to see how this all turns out. And just as a last question, Vanishree, before we close today's discussion, for anyone interested in the audience, where can we follow and engage with you and Fermah?
I think Twitter is a great place, and another good place is go to fermah.xyz, fermah.xyz, and we have a forum there. Projects who are embracing ZK, I think pretty much in every project that is embracing ZK, we may have a way to add value and help in one way or the other to them. We love collaborating. Would really welcome anybody in the ZK space to join hands, and we are looking towards a collaborative future.
Yeah, thank you, Vanishree, and thank you so much again for all of the insights that you brought today, from the importance with collaboration, and then the ZK space as a whole, the cryptography space as a whole as well, and then also what you're working on in Fermah with improving the proof generation aspect, working on the data predicted proving delegation component as well. All very great insights. And again, thank you so much for being here today.
Thank you too. Thank you both, and great questions. I had a lot of fun. Thanks.
Yeah, thank you.